Let's take some time and let's dive deeper into the full depth and breadth of our software portfolio and see how it supports the data and AI lifecycle. When asking a question, the first thing we start with is getting access to data inside of an organization. We have to be able to discover data, analyze it, and build an inventory. And we capture this data in the data catalog, where we create metadata and we profile the quality of that data. In Viya, we do all of this inside of an application called Information Catalog. Let's take a quick walkthrough or a demo and see Information Catalog at work. Here you can see that Information Catalog is surfacing metadata about assets inside of our deployment, including data. Using search, we can do things like find a data set that contains a specific column. In this case, we're looking for the column named default. You'll understand what default means more in a little bit. And we're going to drill into the FinServ ABT table. As we do that, we can start to see things like measures of completeness and the physical size of the table. And because issues with data privacy, sensitivity, and compliance are so important, Information Catalog automatically looks for and flags these things for you. Things like age, race, and gender. Data is intellectual property. It's a competitive asset, and we can use Information Catalog to be good data stewards, adding things like descriptions, contacts, and tags, which enable better searching by and collaboration with others as data propagates throughout the enterprise. But let's go back to this default column that kicked off our search. We can quickly see the distribution of ones and zeros in our column, and in this case, the default name of the column is referring to a loan default. So a 1 means yes, a person defaulted, and a 0 is good. As we look at other columns, we can see things like outliers that we might need to go look at, and we can quickly look at columns for things like race and gender and get a sense for whether our data might contain some representation bias that we need to be aware of. As we look at columns, for example, age in this case, we can quickly understand whether we might need to do things like some binning or maybe deal with some skewness in our data. And we get data quality metrics for everything. And because we get indicators for data privacy and sensitivity, we can quickly make decisions for things like maybe masking values inside of our data. And we can quickly look at the actual data inside of our table. And once we're ready, we can approve this data and then move on to doing other things like visualization and exploration, or maybe modeling. Now, I love to write code just as much as any developer, but hopefully you can see how fast someone can fly through all of this, making important and very strategic decisions about data without having to write a line of code. The next step is data management, joining data from different data sets, doing things like adding new calculations, deriving columns, and performing additional transformations. And we do all of this as we're getting ready for analysis. From there, the goal is to make a prediction or a classification. So you see here on this slide, the column in blue is an indicator of the column we want to predict, our target variable. In Viya, we do all of this data preparation, all of this data wrangling in an application called SAS Studio. In SAS Studio, we can connect to data in multiple different sources, and we can transform it, and we can even build models all right here. We primarily do this in SAS Studio using flows. Flows are comprised of steps, and SAS Studio comes with tons of steps ready to use out of the box. All of this gives you a visual, low-code, no-code experience, making users incredibly productive as they work with data. We can do things in this flow like use a query node to maybe join some tables, or we can use a bar chart node to generate some quick visualizations. You have all this flexibility inside of SAS Studio, even using the language that you're most comfortable with. Of course, we support SAS code, but we also support Python. And I can even use SAS and Python together interchangeably if I want. Where else can you do that outside of SAS? SAS Studio also enables you to create custom steps that you can share with colleagues inside of your enterprise, enabling greater collaboration across teams. This lets you create additional low-code experiences that are custom to your data and your problems, and it can help you standardize your code and your best practices. Remember that Futurum study Brian referenced? All of these things, they're all building to that reality of it taking significantly less time to perform a task, often 6 minutes versus 4 hours when we're comparing ourselves against the competition. Now, inside of SAS Studio, we can, of course, easily look at our input data, the data that we have been prepping for modeling, and we can do that directly here inside of the user interface. Now, we can also easily go and look at a bar chart, that bar chart that's being created by our flow, which, remember, is just one of the out-of-the-box steps that's available in Studio. And with that bar chart, I can start to see how different loan types map to a loan default status. SAS Studio also easily lets me take a flow, which, remember, just visually represents code logic that we want performed on data, and I can schedule that flow as a job, then automating that task into the future. Now that we have the data, we've prepped it, we've wrangled it, we're ready to take the next step. That step could be going directly into modeling, or it could be going into deeper visualization and exploration and even basic reporting before we're ready for modeling. And that's exactly what we're going to do now. Often, users want to do an exploratory review of their data. They want to understand things like the relationships between their target variable, the thing they're trying to predict, and other variables and columns in their data set, all toward the goal of starting to build intuition as to what modeling techniques might work best. As users seek to build that intuition, they might also want to make sure that the distributions in their data support those modeling techniques they want to use. In Viya, we can do all of these things inside of Visual Analytics. Inside of Visual Analytics, users, who are often business analysts, can quickly and easily explore and visualize data. As they do that, they can create reports for distribution, or they can even create quick model prototypes. To get started, users can choose from an out-of-the-box template, a custom template, or they can start from scratch. Everything inside of Visual Analytics is designed toward productivity, ensuring users can accomplish their goals with no wasted effort. As we get started building a report, we can see the variables in our data set, and they're organized by type. As we hover over variables, we can see that we get similar metadata that we've already seen in other tools. They're indicators for sensitivity, privacy, and even outlier alerts. Now, coming back to our financial services use case, we can look at this target variable for default, which again indicates whether someone has defaulted on a loan product. Using automated explanations, we can quickly see what other variables in our dataset might have predictive power as relates to this variable default. We can quickly understand any correlation between potential predictors. We can explore the distribution of our variables. And as we do that, we can leverage the ability inside of Visual Analytics to quickly try out different visualizations on the fly with the simple click of a button. Again, no code, just wicked fast. But remember, our goal is to build a model that predicts loan default. And we can do that right here inside of Visual Analytics. We can go back to that automated explanation of our default variable, and we can choose between a number of different modeling techniques that are available, again, with the click of a button. We can then easily look at the results of those models, and we can do a model comparison to choose the best fit for this loan default use case that we're going after. And once we're happy with the model that we have a number of options for next steps. We can take that model and we can push it into Model Studio, because maybe we want one of our expert data scientists to refine it a little bit, try to eke out a bit more accuracy. Or we can publish that model into our model repository. We can even directly download the model scorecode so we can take it into an external application. Hopefully you can see how Visual Analytics allows you to quickly fly through data, gaining a deeper understanding through exploration, and then quickly moving into modeling, all by dragging and dropping. Everything is just a simple click away. Okay, so earlier, I was talking about how one option inside of Visual Analytics was to push a model into Model Studio for deeper refinement. Often, to get models to the level of accuracy we want them in order to achieve our business outcomes, we need to be able to do things like feature engineering or ensembling the result of multiple models together. We also want to be able to run model tournaments, where we can run dozens or even hundreds of models against each other, comparing their performance. Obviously, the goal here is to pick the model that performs best, declaring it our champion. In Viya, we run all of these model tournaments in an application called Model Studio. Model Studio is a machine learning sandbox of sorts. It allows data scientists to be more productive. They can build more models, and they can do that faster. In Model Studio, analytical operations are represented as nodes. And nodes, they get organized in a pipeline. And Model Studio makes it really easy to go and to add nodes to a pipeline with just a few clicks, allowing you to quickly build out your data science workflow. This is a low-code, no-code experience that gives users the ability to rapidly iterate. And that iteration, it's really important because a user, they might want to run through multiple experiments. And as they're running through those experiments, they're trying out different options. They're trying out different ideas. They can test out things faster. Once again, we're making them more productive. And you get this experience, all of this interactivity, regardless of whether you're using SAS models or Python models. Of course, within Model Studio, we can go and we can take a deeper look at data. As we're looking at data, we can see similar metadata that we've seen elsewhere. Do we have things like missing values? What's the mean of a variable? You can set variables to be assessed for bias, so that even if you're not using a variable, you can understand the effect that it has on your data set and on the problem that you're trying to model. All right, so we've understood our data, so let's go back to our pipeline. And as we come back to our pipeline, remember, I mentioned being able to use both SAS models and Python models. Now, Model Studio is going to make it straightforward to use Python and use the Python packages of your choice. And even if you're using Python, Model Studio is still going to keep you productive. And it's going to keep you productive by helping you generate all of the assessment information that's going to ultimately help you determine whether this model is the best model or not. As we start looking at our assessment information, Model Studio is going to help us further, and it's going to do that by generating natural language explanations. Those explanations tell us about the performance of all the charts that we're seeing. These explanations can help us gain a deeper understanding of what a model is doing, but they can also help us if we're collaborating with others on our team, people that might not know as much about the problem as we do. It helps them learn quickly. And it isn't just about assessment statistics. We also get detailed information about fairness and bias. Remember, we're looking at a loan default problem, so we need to understand whether we're unfairly impacting individuals based on things like gender and race. Okay, so far, we've just been looking at one pipeline. But remember, Model Studio helps you generate multiple pipelines, and we can do that to test out lots of different ideas. When you create a pipeline in Model Studio, you can do it by starting from a blank template, or you can actually ask Model Studio to use AI and to use that AI to automatically generate a pipeline that it thinks is best suited for your data and for your problem. Or you can use an existing template that someone in your organization might have created, again, maybe incorporating some best practices. Now, creating multiple pipelines, it lets you test out multiple ideas in parallel, again, making you more productive by enabling you to iterate faster. Now, regardless of how you created a pipeline, whether you did that from scratch, or whether you used AI or used a template, Model Studio makes it easy to quickly look across all of your pipelines, comparing how your models are doing. And remember, as we're comparing models, we're looking at those models, whether they're SAS models or whether they're open source Python models. Now, finally, as we're comparing pipelines, we get this amazing Insights tab. And that tab helps you rapidly understand all that you've done inside of your project. And you could use that to understand work you've done, but you can also use it to help educate your colleagues. You can use it to help collaborate with people that might be working on the same problem. Okay, so that's Model Studio. Hopefully, it's pretty clear by now that if you're using Model Studio, you're going to have, wait for it, models, and potentially lots of them, which takes us to the next part of our journey. In many organizations, there are dozens, hundreds, sometimes even thousands of models created. These models, they are intellectual property, they're assets, they're decisioning assets. That's why we need model management. You need a place where you can store and centrally manage models in one location. In Viya, all of this happens inside of Model Manager. So let's take a quick look at that. Model Manager lets us govern these important assets. We can monitor them, and we can easily update them over time as their performance changes or degrades. Model Manager organizes models inside of projects, and a project is a collection of models that address the same business need. Here we are looking at our FinServe project, and inside of this project, we've registered both our SAS and Python credit scoring models. Now, Model Manager has a ton of valuable information about the models that are being managed, but let's spend some time looking at our newly released model cards. Model cards are like nutrition labels for your AI. They focus really on model accuracy and model fairness, with all of the necessary supporting details, all of the checks and balances. We can quickly see how accurate is our model. Does our model generalize? And is it fair? And with just a glance, we can see here that we probably need to follow up on this failing grade for our race variable. The model card, it's telling us that we haven't used any sensitive variables in our model, but we still might want to take a closer look. We can also see the variables that have the most predictive power. We can then continue on and we can see the model's published status and information about any limitations that the model may have. We also get information about the model's intended use. That information can provide guidance to our modelers and our data scientists as they're working back and forth during the training process. We also can then move forward and we can get a synopsis of our training data, all of the columns, all of the rows. We can see tags on data, which variables are considered private and sensitive. Remember, these are things that we've been following all the way through from Information Catalog. A critical piece of information that's flowing into this model card that we saw back in Information Catalog is the notion of data being approved. It's really important in a production scenario to know that our data is production ready. Now we can move on to the model summary. That's next. And inside of a model summary, we're going to start to see multiple accuracy metrics. We get things like a confusion matrix, and we get a fairness assessment as well. So we can see those accuracy metrics, we can see that confusion matrix, and we can then see our fairness assessment. Finally, as we move forward in our model card, we get to the model audit section. Here, we can define custom alerts that trigger when things like accuracy and fairness fall outside of an acceptable threshold. So hopefully, you can see how model cards can connect multiple personas across every level of the organization. Data engineers, data scientists, people doing model ops, even the C-suite, and it's all accessible here in a single location. Okay, we've got models. We're governing them. What's next? Often, given the nuances of data, or just the sheer complexity of the problem you're trying to solve, you need to combine the output of models, multiple models, with rules in order to make better decisions. And in Viya, we let you do this with intelligent decisioning. Here we are inside of intelligent decisioning. Now, this interface may look similar to things that we've already seen, but again, in this case, we're looking to combine models, business rules, and more. In order to make a decision, we might need to make a query to a database and retrieve additional columns on the fly. In this case, with our loan decision, maybe we need some information on customer behavior. We can also make API calls to third-party applications. Maybe we want a credit rating from a credit bureau. Users can quickly create branches in a decision. So in our example, maybe we need to quickly check whether our age variable indicates whether our applicant is above 18 or not. We can even create a branch based on the loan's purpose so that we can bring in a specific model that's best tailored for that purpose. In our case, you can see that we're using a SAS model in the case of debt consolidation, but we're using an open source Python model for the other loan segments. Let's take a second and let's take a closer look at the rules that we've defined for credit risk. As we do that, you'll see that we're first looking at our minimum age criteria for a loan, and then we're using the model output to decide whether an applicant is at a high, medium, or low risk for default. So now we've got all these rules in place, we've got this decision flow. Once we're happy with our decision flow, we can jump back over to the Scoring tab, and we can use that tab to quickly see the decisions being output for each row in a test data set. As we do that, we can start to see things like the distribution of rules being treated so that we can see whether our decision flow has been set up properly. We can also see paths that are being traversed through our rules, and we can quickly understand by the thickness of the lines in those paths which paths are being taken more often. Finally, now that we've tested our decision flow, we can easily publish it to a destination of our choice, whether that's a SaaS destination like our microanalytics service or as a container, and we can take that container into our cloud provider of choice. Okay, so now we have a decision flow in production. We can then fit that into a business process, which in our case might be an online loan application where we're making a lending decision. We're done, right? That was amazing. Man, we can exhale. But wait, that model, it's in production. And remember, the world is not static. Things are always changing. We have to monitor the performance of our models, the performance of our decisions, because as the world changes, data shifts, models and decisions decay. But with the productivity of SAS Viya, this isn't a bad thing. It just brings us back to the data and AI lifecycle, where we can iterate and learn,